Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So the first thing you want to do for your factoring is to remove the 9. So you're going to have x squared minus 30x plus 225. And then you're going to replace the 9 and factor. And you're going to want to use negative 15 for both. And then they'll both divide by 3. So you'll have 3x minus 5 times 3x minus 5, which you can write as 3x minus 5 squared. For the math knowledge question, we want to know the dimensions of our dollhouse when the scale is 1 to 12. So we have 36, 84, and 48. So basically, you're going to divide all of these by 12. So 36 divided by 12 is 3. 84 divided by 12 is 7. And 48 divided by 12 is 4. So the only one that has 3, 7, and 4 is B. So that would be the dimensions of his scale model. Okay, so we're going to be looking at lesson 34 today. We are skipping lesson 33 because it's a geometry lesson. We are going to look back at 2 examples from that lesson, but we're not going to spend any time other than those 2 examples from the information because you covered all of it in geometry. So lesson 34 is on summation notation, linear regression, and then decomposing functions. So hopefully after this lesson you'll understand what summation notation is, understand linear regression, and decomposing functions. So looking at this example for the trapezoid, we want to find x, and they tell us the area is 175. So we're going to use our formula for the area of a trapezoid, which is 1/2 base 1 plus base 2 times your height. So hopefully you remember that formula, and we're going to fill in what we know. We know the area is 175. We know that one base is x, and the other base is 2x plus 8. And our height is 10. So now I'm going to multiply the 1/2 by the 10 to make that a 5. And then I'll have x plus 2x is 3x plus 8. So then if you distribute, you'll get 15x plus 40. And then if you subtract, you'll get 135 equals 15x. And then if you divide by 15, x will equal 9. And so that would be the value of x. Looking at one other example, they tell us that EF is the median, and we want to find x. So you may remember from geometry, the median is adding the 2 bases and divide by 2. So your median is base 1 plus base 2 and divide by 2. So our median is 4x plus 1. Our 2 bases are 2x plus 2 and 7x minus 2. And so we add those together and divide by 2, and that equals our median length. So I'm going to cross multiply here to get rid of the fraction and make that 8x plus 2. And then I can combine my terms, and that'll just be 9x. So if you solve for x, x will equal 2. So that's all that we're going to do with lesson 33. We're going to move on now to lesson 34. Looking at summation notation. The notation is going to consist of the Greek capital letter for sigma. And sigma is used because it's the Greek version of S, which is the first letter of the word sum. So we use sigma because it's a summation, starts with an S. And it doesn't look like an S, but this is sigma when it's a capital letter. And this is what a typical summation notation problem would look like. So the 4 is the greatest value, the 1 is the least value, and our variable that we're going to use is a y here, because that's what they give us right here. And then the y squared is a typical element. So what you're going to do on these, we're going to start with 1, and we're going to plug in every integer up to 4, and we do plug in 4. So we would do 1 squared, 2 squared, 3 squared, and 4 squared. And it's a summation, so you add those all together to get your answer. So 1 plus 4 is 5, plus 9 plus 16 gives you a 30. So that's what this answer would be. Okay? So let's look at an example. We want to evaluate this. Whenever we plug in 1, we get 3 because there's no I here. So every time when we plug in a variable, plug in for our variable, we're just left with 3. So when I plug in 1, I get 3. When I plug in 2, I get 3. When I plug in 3, I get 3. Same thing for 4, and same thing for 5. So 1, 2, 3, 4, and 5 threes, that's a total of 15. So that's how you would do that one if there's no variable. Let's look at another one. This one says 2x. So we're going to start off by plugging in 1. They don't always start with 1. This one just these ones just happen to have started with 1. When I plug in 1, I get 2 times 1, so 2. When I plug in 2, I get 4. When I plug in 3, I get 6. And when I plug in 4, I get 8. And so if you add those together, 2 plus 4 plus 6 plus 8 is 20. And so that would be your answer for that one. Now we're going to look at another example. For this one, we're going to start off by plugging in 0. So I'm going to actually do this, and then we'll simplify them in a minute. So when I plug in 0, that's what I would get. When I plug in 1, I would get this. When I plug in 2, it looks like that. And when I plug in 3, it looks like that. And I did it out like this because it wasn't super quick to do in my head. So 2 to the 0 is 1, and then 0 plus 1 is also 1. So 1 over 1 is just 1. 2 to the 1 is 2 over 2. So 2 over 2 is 1. 2 to the 2 is 4 over 3. 2 to the 3 is 8 over 4, which is 2. So I have 1 plus 1 plus 4 thirds plus 2. And when you add those together, you should get a total of 16 over 3. Okay, so that's how that one would work. We're going to look at one more. If y'all think you can try this one all by yourself, go for it, and then I'll go over it after y'all have unpaused the video. So we're going to start off by plugging in 4. So we're going to have 1 over 4 plus 1 over 5 plus 1 over 6, because you just plugged in 4, 5, and 6. So the common denominator is going to be a 60. All of those are going to go into 60 evenly. This 6 would get multiplied by 10, so 1 6 is going to become 10 over 6. The 5 would get multiplied by 12, so 1/5 would be 12 over 60. And then the 4 would get multiplied by 15, so it would become 15 over 60. So if you add those together, you should get 37 over 60 for your answer. Okay, so that's how you do summation problems. They're not difficult, but you do have to know what to do with them. So now we're going to look at linear regression. So they're always going to give you this paragraph, and it basically, the only part you need to know is you're writing an equation of a line, and it's going to look like this. It's in y equals mx plus b format, but s and c instead of x and y. And s and c, s is for salt, c is for carbon. If you know, I know that salt is not, its elemental name is not S. If you know it, you're welcome to use it. But really, they just pick the first letter of the name. So don't stress about, well, that's not its name. It's NaCl, I think it is. It's something else. It's okay. So what we're going to start off with they're going to give us the line, and then eventually that line may disappear and we'll have to draw it ourselves. Basically, we're looking for the line of best fit. So you're going to look at the graph here, and you're wanting to find points on this line that they have drawn for you. And you want them to be accurate if you can. You don't want to have to estimate. So this one looks like it's an accurate point. Looks like it's exactly on the graph. So does this one. And so does that one. So now what we're going to do is find our slope. So this point here is 40 and 0. This point is 100 and 5. And then I could use this 160 and 10 if I wanted, but I'm going to use these other two. So my slope would be y minus y over x minus x. So that's 5 over 60. Which if you've made it as a decimal, you'd get 0.083 repeating. Or you can just reduce it to be 1/12. Okay, so that's our slope, and then we're going to have to find our b. So y equals mx plus b. Our y value, I'm going to use this one, where my y value is 0, my slope is 1/12, and then my x is 40. So 1/12 times 40, those both divide by 4. So because 40 over 12, if I divided by 4, I'd have 10 over 3 plus b. So my b value would be negative 10 over 3. And so the equation that I get is y equals 1/12 x minus 10 thirds. But come back up here. We have to put it in this form. S equals 1/12 c minus 10 thirds. So that would be your answer. Okay? So that's how you do linear regression. It's basically just line of best fit, which y'all may have done in biology before. Okay, so now we're going to move on to decomposing functions. Some people get these like super fast, and then some people struggle with these the whole time. It just depends on your brain, how you think of things. It's not a determination of whether you're intelligent or not, or whether you can handle pre-calculus or not. Just some people get these so much more quickly than others, and I wish there was a way to make it so you could all get them super fast. It just is what it is. So some of y'all are going to have to work on these a little bit more than other people. So we have the composition. They tell us f of g is the square root of x squared plus 1. And you were trying to find f and g, such that when you compose them, you get this. So you should be seeing two things. One thing is the square root, and the other is the x squared plus 1. So we took the x squared plus 1 and put it inside of the square root. So that means that our g of x is x squared plus 1, and our f of x is the square root of x. And so that would be two functions that would work. Now, there is another one that would work if I wanted to. I could say g of x is x squared, and f of x is the square root of x plus 1. If I took this and plugged it in for x, it gives me that. So technically, either one of those would be right. The book only gives this one, or it would on the answer key only give this one, but that doesn't mean that this one is not correct as well. So you do have to be careful. Just because you don't have the same one as the book doesn't mean that it's wrong. Now, you can't just say one of your functions is x and the other one is what you started with. If you just say g of x is x and then f of x is the square root of x squared plus 1, it's going to be marked wrong. So let's say trivial decomposition, because that didn't really change anything. So don't make one of your equations just an x. Okay, so we're going to look at another one. We want to find f, where it says g of x is x squared plus 1, and f of g of x is 1 over x squared plus 1. So we plugged in x squared plus 1 into our original function. So where we have x squared plus 1, originally we would have had just an x. So that would be the equation for your f function, 1 over x. Because when you plug this in for your x, you get what they gave you. So that's how you do decomposition for functions. You're basically going backwards. And so it does take just a little bit of practice. You got to practice just a little bit, okay? All right, so your homework, you get to omit number 10 and number 27. And then you need to be studying for your trig quiz that's going to happen whenever we do lesson 37. So make sure that y'all start studying for that. You need to be looking at your unit circle daily, or multiple times a day even, and studying. It's going to be 24 points, and it's going to be the first one of 4. So make sure that y'all study those.